Hello and welcome to this video on how it is that some cuttings will strike roots. Cuttings are one of the easiest ways to propagate a plant, and this lets you create many new trees, shrubs, vines and more from just one existing plant. Of course, these are all clones of a kind, but that is a relatively minor demerit compared to the many benefits. The propagating is so simple on its surface means there must be more to it. In fact, there is a lot more to it. And so this is what the video is for. We'll go through what is happening when you try and propagate a plant via a cutting. The process is fundamentally called adventitious root formation. It basically refers to the fact you're forming roots from part of the plant that typically is not a root. For example, a node for a maple tree. Now these roots will form part of a normal tree's development, normally due to stress. For example, if the tree has been damaged by falling over, if lightning has struck it, and so on and so forth. The response is entirely normal, but nearly always used in practice is a wound response when you cut off a branch, and it's used quite commonly in nurseries. Now, in order to get propagated cuttings, this has to happen. Without the adventitious roots, or the roots taking or developing, you won't have a cutting, you'll have a relatively short-lived stick. Fortunately, there are a variety of species that already effectively have these adventitious roots. Ivy is a very common example where you see them growing. Creeping figs are another. There are many species where the adventitious roots are already there, but in other species you need de novo adventitious roots or new adventitious roots that will form only in the meristematic area, and this is pretty much going to be done by removing leaves, having the tree think, well, the leaves have fallen off because, say, the branch has fallen to the ground or the tree's fallen over or similar, in very crude terms, and therefore it needs to form roots to support the tree's growth again. In other instances, it's going to be wood-induced de novo adventitious root formation, and these are less commonly forming, mostly because they're limited to mostly herbaceous plants, so bananas, chrysanthemums, and similar. There are also some species that really don't like doing this, particularly dense and heavier wood species, for example oak. So generally speaking, you don't use this for those species, or at least you don't use this for those species when they're younger, for instance. You nearly always use mature stock. The process at a molecular level, that is what's going on inside the tissues and the cells, is a little bit more complicated again. So we now have two primary pathways, that is the existing roots or de novo roots, and to get either of these you need something called jasmonic acid. This is what signals the development of these adventitious roots to form. When the cutting is taken, let's say, various inhibiting hormones that are meant to stop roots from forming randomly are no longer able to work as intended. They're basically blocked from being formed. Along with this, you get certain other hormones, such as cytokinins and stroglolactones, and these travel to the area of damage, where, when they reach a certain concentration, or there's not enough of them present, you end up with the formation of something called auxins. Auxins are a very common hormone that tell the tissues to start growing. And as you can see, there's a decrease of some and an increase in others. You need just the right concentration to tip the balance in favor of one of these, which leads to the cascade of certain signals. This signal cascade leads to the development of roots. The initial step is to get the primordia, or the root primordia, from the cambial cells in the stem. These are then going to be related to what was previously leaves, and these primordial roots are formed from here. These come out of the basal callus tissue after the primordial leaf emerges. Now understand, there is a sort of second cluster of, or second pathway of cuttings you can take, and these are where you have a node. Understand, if you're cutting at the node, you get instead meristem tissue, and this is what's going to form at the end of the cut. This will in turn also be able to form roots. It's mostly the same process, just understand there's a slight difference in the mechanisms. In order to make this happen, we have evidence going back nearly 100 years now on exactly what is required, and it is, simply put, that auxin. Auxin is needed and in many cases is artificially applied to where the plant has been cut. By doing this, you increase the adventitious root development. Now, you don't necessarily need it. As we've mentioned with other scenarios, it's certainly not necessary for all species and in all situations, and you may have a fairly successful strike rate without it, but it can be useful to include. The actual use of itself is, well, as I said, quite old, at about 80 years now, and it may also be used to apply to cuttings that are used inside of scions and grafts. Of course, again, we're talking about pretty much synthetic scenarios where you're trying to put it into, say, rootstock. But if you're trying to simply plant a cutting as it is in a tree in its own right, you're going to have to look at certain processes, let's say. The major things you need to worry about are going to be light and temperature. Basically, your environmental signals saying that, yes, you should actually be growing now because this is theoretically a good time of year for you. Generally speaking, it's going to be moderate temperature, so roughly 20 degrees Celsius or somewhere between 60 and 70 freedom units. You have this temperature and a reasonable amount of light. Obviously, you're not going to be getting 12 hours, but certainly at least 8 or so, which will end up producing that auxin, so you artificially encourage its production, simply by putting it in an environment where it's most suited to doing so, rather than having to, well, apply it separately. If you are lower than this temperature, you unfortunately get cytokinin production instead, and this is generally adverse to developing new roots, as it affects the production of the hormones needed to encourage root development. Being at a somewhat higher temperature than this isn't necessarily bad, but you run the risk of issues around secondary problems with the roots developing. For the most part, the biggest issues you're going to have to worry about are going to be things like dry soil, as this is going to hurt the roots and cause it to go into a stress response much sooner, and as a result, it's not going to prioritize that adventitious root development, but instead it's going to be trying to just survive, which, without roots, won't last for very long. Your other major worry, to a certain extent, is light. Now, as we said, you don't need extreme days, so basically summer-length days of light, but you want to keep it at a reasonable amount. There is an argument to be made that keeping light low is actually better, as this will alter the amount of vapor pressure that occurs. That's basically the small amount of heat generated from the naturally occurring light, even for a short time, may lead to an increase in evaporation, which would in turn increase the stress on your trees, or cuttings in this case. But once the roots start to form, a light can be increased according to this research, so it's not as though you need to keep them in a good quality long-term light, so artificial lighting in some cases, but you also don't necessarily want to keep them in the shade the entire time. In fact, to some extent, once you start seeing the roots developing, you probably should move them into more light to allow for photosynthesis, and therefore production of everything else the tree will need to grow once the cutting is taken. This is how your cuttings go from a future twig to a future tree or similar. Admittedly, a somewhat simplified explanation, but a reasonably complete explanation for most purposes. You'll find the link to the publications we've used below if you want to read further details on what we've explained in this video. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.